This is the Golden Gate, a mile of freezing violent water between San Francisco and the open Pacific. Every engineer who studied this channel between 1910 and 1920 reached the same conclusion: do not touch this water. The currents beneath it ran faster than any river on Earth, the seafloor was cracked and unstable, and the fog made it impossible to see your own hands. But San Francisco was dying because the farms, the factories, and the workers who kept the city alive were all on the other side of that water, trapped on a peninsula completely surrounded by water on three sides. To go north, you risked your life on rusted ferries through blinding Pacific fog. A bridge was the only answer. And every single expert said it was suicide, and this is the true story of how America built this bridge. Joseph Strauss wanted this job more than anyone alive. He was not the greatest engineer, he was the most obsessed, but the man who actually made it possible. History buried his name for 70 years, but don't worry, we will find him at the end of this story. The federal government refused to pay a single dollar, and the state refused to pay a single dollar. So city officials did something almost no city in American history had ever done. They asked ordinary families to personally guarantee the bonds. Farmers signed their land, homeowners signed their houses. It was 1930, the Great Depression won. In 4 Americans had no job, and thousands of them signed anyway. When the last signature was collected, the total stood at exactly $35 million, every cent of it, backed by the homes and land of ordinary people. With the money finally secured, construction broke ground in January 1933, 4 years after the first family signed their name. To build this bridge from nothing, engineers had to complete 7 operations, the 5th that had never been attempted by anyone anywhere on Earth. North Tower. The North Tower side was almost generous. Solid bedrock sat close to the surface, and workers built that foundation in months and moved on. But how did they actually build it? Every answer is on the south side, and that is where we are going next. The South Tower, to make the mathematics work, it had to stand in open ocean, not near shore, not in shallow water. 1,100 feet from land, in 100 feet of freezing water on a seafloor that was cracked, fractured, and sloping at unpredictable angles. Before they could build anything, they had to reach the bottom of the Pacific. So workers hammered a wooden pier straight out into the open water. Nature immediately fought back. A cargo freighter, blinded by fog, plowed straight through the pier. Months of timber work destroyed in minutes. They rebuilt it. Then a winter storm swept through and carried millions of dollars of equipment out to sea. They rebuilt again. These men fought the ocean just to reach the point where construction could actually begin. Foundation, the divers. To anchor the South Tower, they needed to flatten the ocean floor, which meant sending men down to place explosives on a surface they could not see. The divers wore 200 pounds of brass and lead and dropped into water so dark they could not see their own hands. They had exactly 20 minutes, the window between tidal surges, when the current slowed enough to allow a human being underwater. When the 20 minutes were up, the current came back, and if you were still down there, you did not come back up. Working entirely by touch, they pushed dynamite into the crevices of the rock, then they were hauled back up by rope. Then the plunger was pushed, and the ocean floor shattered. They did this over and over for months, carving a flat platform into the bottom of the Pacific Ocean by hand, in darkness on a countdown. The fender, bathtub. But explosives alone were not enough. To pour a foundation 100 feet underwater, they needed dry land. So engineers designed something that had never been built at this scale. A massive concrete bathtub the size of a city block. They built it on shore, then deliberately sank it to the seafloor. Steel guide tubes were dropped to the cracked bottom, then millions of pounds of concrete were pumped down to seal it. Once the concrete cured, they threw the pumps into reverse and sucked millions of gallons of seawater out of the tub. Suddenly, there was dry land 100 feet below the Pacific Ocean. Inside that dry pocket, they poured the true foundation, a solid concrete island rising up through the water to the surface. The base was finally set. Steel climbing into fog. Manufactured in Pennsylvania, shipped by rail across the continent, then sailed through the Panama Canal just to reach this site. Now, 83,000 tons of custom-forged steel arrived by ship, every single piece coated in bright red-orange lead primer to fight the Pacific salt air. And now it had to climb 746 feet into the sky. Engineers designed a machine that climbed the building as it grew, a creeper crane that hauled steel sections straight up from the rocking barges below. When it finished one level, hydraulic jacks pushed the entire rig higher. But the crane only placed the steel. The rivet gangs locked it together, rivet gangs. 4 men working in mechanical rhythm on beams barely wider than their boots. Step 1. The heater baked an iron rivet in a forge hanging in open sky. Step 2. At exactly the right temperature, he threw it. Step 3. His partner caught it in a metal cup from 30 feet away. Step 4. The third man pressed it into position and the fourth drove it home before it cooled. One slip, one bad catch. One moment of lost grip, 700 feet to the water. But up here, the real enemy was not the height, it was the wind. Sudden Pacific gusts slammed workers sideways with enough force to tear a man off a beam. Workers learned to read the wind by the sound it made. They became, as one foreman wrote, something like dancers. Precise, instinctive, aware of forces invisible to anyone watching from below. After months of this, a final rivet was driven into the top of the northern tower, taller than anything standing west of the Mississippi. But 2 towers across a mile of open air are not a bridge, they are 2 towers. What had to happen next had never been done at this scale by anyone anywhere. The cables, spinning wheel. The gap between the towers was 4,200 feet. Across that gap, they had to build cables strong enough to support 200,000 tons. Each cable, nearly 3 feet thick, built from 27,572 individual steel wires wound into a single artery. Here is the problem. A cable that size cannot be manufactured anywhere on Earth and transported to a bridge site. It is too heavy to ship and too thick to wind, so they built it in the air wire by wire. At the site, thick steel rods were pulled through a series of narrowing steel dies each pass, making the wire thinner until it reached the exact diameter needed. Each finished wire was immediately coated in zinc to seal it against the Pacific salt air before it was loaded onto the spinning wheel for its 4,200-foot journey. A spinning wheel on a traveling carriage was strung between the towers 220 feet above the water. It traveled back and forth across the full mile of open sky, carrying 2 wires at a time. The wheel ran 24 hours a day through everything the Pacific threw at it, catwalks. But to make this work, someone had to walk that span and check every single wire by hand, on rope catwalks 3 feet wide. The Pacific fog was so thick on some days that workers could only locate the catwalk by feel. And the spinning could never stop. One loose strand and the cable geometry collapses. The entire timeline, backed by mortgaged farms, stopped every time an alarm screamed. For 6 brutal months, the wheel never stopped running until 27,572 wires were squeezed into one solid mass. Then, a wrapping machine spun a tight skin of wire around the outside to seal it from the salt air forever. The result was a 36-inch artery of pure steel, the only reason this bridge is still standing 90 years later. Roadway, the seesaw. Once both main cables were locked to the tower tops, the suspender ropes dropped straight down. And from those ropes they began hanging the road. Steel deck sections lifted from barges 220 feet below and bolted into place. But the bridge was a seesaw balanced on 2 towers. Any imbalance and the towers twist. Every time they hung a section on one side, they had to match it perfectly on the other. But there was a force nobody had fully accounted for. Bridges do not just sway in wind, they begin to oscillate. A rhythmic twisting that starts slow and imperceptible and builds. Engineers added stiffening trusses beneath the deck and widened the structure to fix a problem they did not fully understand. Then they poured the concrete driving surface, millions of pounds of wet concrete added to the deck. As the weight built, the cables stretched and settled into their final curve. Safety net, $130,000 gamble. In 1933, the industry standard was 1 dead worker per $1 million spent. The math said 35 men would die building this bridge. Joseph Strauss refused to accept that equation. He hired a nutritionist to design a special diet for workers and created the first mandatory hard hat zone in history. And then he spent 130,000 Depression-era dollars on a circus-style safety net strung beneath the entire construction area. That net saved 19 men who fell from the steel. They formed a group called the Halfway to Hell Club. For 4 years, not a single man died above the deck. Tragedy. Then, on the morning of February 17, 1937, a 5-ton work platform broke free and hit the net. The net held for 10 seconds, then the weight tore through. 12 men fell 220 feet into the Pacific. 2 survived, 10 did not. 11 workers died in total building the Golden Gate Bridge. Without the net that Strauss fought for, the number would have been 30. He saved 24 lives through pure obsession, but those who fell are as much a part of this bridge as any cable or tower. The final temperature. By November 1936, a single 10-foot gap remained at the exact center of the span, and they could not close it. When the temperature was right, the crane lowered the final beam, and it fit, the gap closed. As the concrete driving surface was poured, the cables stretched and settled into their final curve. Then the architect looked at the raw orange-red primer and called it International Orange. The Navy wanted yellow stripes. The Army wanted red and white. He said no to both. It was the only shade visible through the fog, and as the world now recognizes, it was perfect. The erasure Ellis reveal. On May 27, 1937, the Golden Gate opened. 200,000 people walked across it before a single vehicle crossed. Joseph Strauss gave a speech that day taking credit for everything, and almost nobody questioned it. But here is what history buried: the load calculations, the cable geometry, the structural mathematics that hold this bridge together. That work did not belong to Strauss. It belonged to one man, a quiet professor named Charles Ellis. Ellis spent 9 years solving the mathematics of this bridge, working by telegram with engineers across the country, thousands of pages of calculations that filled 10 volumes. In 1931, Strauss called him into his office and fired him by telegram 3 days later. It was the Great Depression. Ellis had no income, but he kept working anyway, 70 hours a week unpaid, in his apartment, because there were errors in the calculations that could kill people. He sent his corrections to the project. They were used. His name was not. When the bridge opened, Strauss gave his speech. Charles Ellis was not mentioned. The plaque on the bridge listed 12 engineers. Ellis was not on it. The actual structural blueprints of the Golden Gate Bridge are signed by Charles Ellis. His signature is on the drawings. His name is not on the plaque. He died in 1949 with no public recognition. Not a single newspaper covered his death. It took until 2007, 70 years later, for the Bridge District to officially acknowledge him as the primary designer. Today, the Pacific still attacks the steel, while 38 painters work year-round finishing one end and immediately starting over. In 1989, a magnitude 6.9 earthquake collapsed the Bay Bridge nearby. The Golden Gate absorbed it and stood. The families who mortgaged their farms are long gone. Charles Ellis is long gone. But his mathematics still stand, holding 200,000 tons, 746 feet above the Pacific every single day. 112,000 people drive across the work of a man whose name they have never heard. The Pacific has been working to take it back for 90 years. It has not succeeded. Because some things, once held together by the right mathematics, simply do not fall. Subscribe for more untold engineering stories.